I have been working on my next video about UniFi Syslog Deep Dive. During the process, I realized there is a special data flow that's worth being called out, so I separate a subtopic into this video, which is about IP reputation blocking. When you see the title of this video, you may wonder, what do you mean by IP reputation? So here I'm showing you a web page from Proofpoint. You may know ubiquitous cybersecurity. The IDS, IPS signatures are provided by Proofpoint. Here you can see the definition of IP reputation. It is a digital trustworthiness score for an internet address. It measures the credibility of an IP based on its historical behavior in online activities. If you want, you can read how it's calculated and what's IP reputation attack. And here it compares the IP reputation and the domain reputation. So here you can see how the IP reputation is evaluated. For example, the sending history include factors like spam complaints, bounce rates, blacklist status. Then the next question is how it's even related to UniFi gateway. Because from nowhere, you can even see the wording of IP reputation on the web UI. Remember, the web page we just viewed is from a company that provides the IDS, IPS detection signatures, right? So the IP reputation blocking functionality in UniFi gateway must be related to IDS, IPS somehow. So in UniFi network controller, in my lab environment, you can see under settings, cyber secure, I do have the regular IDS enabled. You can see the detection mode is notified. I have all these detections enabled. Based on the current setting, if I SSH to the UDM Pro, let me show you the IP tables. Let me run iptables command. I'm only going to show you the filter table, which is mainly associated with firewall rules. And here I'm using GRC to run it. It's just a tool to make the display colorful for easier understanding. GRC is not really necessary here. Okay, let me run it. It's a long list of firewall rules. If I scroll to the very beginning, you can find these 4 chains. So the first two has the name alien, and the next two has TOR in the names. So they are almost identical except for naming. See this alien chain? It's very simple. It will call another chain named as alien log and drop chain, right? However, there's a condition. The source IP address has to be in this list, which is called alien. In the alien log and drop chain, it will do 4 things. If the source IP address is in this white list, it will skip it. It will allow it. And if the destination is in the white list, it will allow it. Otherwise, before dropping the packet, it will run this target, which is called nflog. Later we will discuss what it is, but here you can see it will produce a log with this wording. Once the log is done, it will simply drop the packet, right? This is for the alien chains. And the next one, TOR chains, just from the name, you can already guess it's somehow related to P2P. So it has the same pattern. These 4 chains are so strange because it seems they are here for no reasons. No matter how hard you search on the UniFi network controller settings, you won't find a setting named as alien or TOR. At this moment, if I go to UniFi network controller, disable intrusion prevention, which means I disable IDS, IPS, apply changes. Then let me clear screen and run the exact same command again. And this time, if I scroll to the beginning, I don't see those 4 chains anymore. They are gone. So that means they come and go simply because we disable or enable intrusion prevention. Perfect. At least now we have a starting point for our investigation. Next, we need to find out which IDS, IPS detection categories are related to the alien and TOR chains in IP tables. So at this moment, we see 6 categories in my active detections section, right? If you go through all of them, you will find the first and the fourth categories. They are very possibly related to what we are trying to find. For example, the first category, botnets and threat intelligence, they are all kind of host list. And for the fourth categories, peer-to-peer and dark web, you can even see TOR here, right? Then what I'm going to do is very apparent. I will try to switch on and off different lists, try different combinations. At the end, conclude which exact list is related to what we are trying to find. This is a time-consuming process. I will skip it in this video. Instead, I will directly show you my conclusion. Let me show you first combination. So you can see for the first category, I only deselect malicious hosts. And for the fourth category, I only deselect dark web block list. Based on the current configuration, let's see in SSH, are we still seeing the IP table chains related to TOR and alien? First, try TOR, nothing. Then alien, still nothing, which means TOR chain and alien chains we see in IP tables, they have nothing to do with the currently selected list, right? So then let me try the other way. For the first category, deselect all, only select the malicious hosts. For the fourth category, deselect all, then only select the dark web block list. Okay? Then in the SSH, let me try the same command for alien. Yeah, I do see alien chains. What about TOR? Yeah, TOR is also there. Okay, we have found the two lists which contribute to the TOR and alien, right? The next thing, we need to understand which list is for which exact chain. That's easy. So let me deselect dark web first. Apply changes. Then in the SSH, let's see whether we still have the TOR chains. Nope. Whether we still have alien chains. Yes, so this confirms the dark web block list is for TOR. Then let me do it the other way. Enable dark web list, then disable the malicious hosts, apply changes. Do we still have the alien chains? No, we don't. Do we still have TOR chains? Yes, we do. Okay, which means the malicious host is about the alien chains. Okay, now we have completely finished this exercise to find out the relationship between the IDS, IPS detections and our IP table chains for alien and the TOR. Okay, move on. Now we need to understand where the IP tables get the two lists, one for alien, one for TOR. Let me show you the IP table rules again. This is for alien and this is for TOR. So you can see the system will run this log and drop chain only if the source IP address match the TOR IP set, alien IP set. If I show you the alien IP set, because there are a lot of entries, so let me use more. You can see there are totally 609 IP addresses in this alien IP set. Then for TOR, there are 5338 entries. Where are this many IP addresses even come from? So if you watched my previous video about how IDS IPS works in UniFi Gateway, you may know the system saves the downloaded detection signatures and lists in a particular folder. It's under USR share in this Ubiquiti folder under IPS under rules. And here you can see all the rules used by IDS, IPS, and you can see two list files, alien, TOR. So if I show you the alien list using VI, you can see here there are 609 lines. It matches what we saw in IP set, right? Then let me show you the TOR list. Yeah, you can see there are 5338 lines, exactly match what we saw in IP set. So we got answer where the two IP sets for alien and TOR, where they come from. They come from IPS. Okay. Now it's time to see it works in action. You can see in UniFi Network Controller for IDS, IPS, I already enabled those two related detections. And then in the lower part, I have two SSH sessions to UDM Pro. In the left side, let me show you the IP set for alien. What I want to do is I want to use a random one, let's say the very first one. As an example, I want to simulate a connection from this IP address to my local machine. To see the effect of the blocking, I need to show you the logs in real time. In the next part of the video, I'm going to discuss the details about the Syslog data flow. For now, just bear with me. Let me directly show you where the log is. In the right side terminal, let me go to var log ulog. Then you can see there are already three files. This particular file, alienblock.log, is for alien, and the third one, tor block log, is for tor. To monitor the alien block log change, let me run tail and specify the alien block log. At this moment, nothing's happening. In the upper left of the screen, I have two Linux virtual machines. They belong to two different VLANs. The reason I want to use two different VLANs is I want to force the traffic to go through router. That's the only reason. In the left VLAN 88 machine, let me show the IP address. It's .88.103. Then in the right part, let me run this command. The tool is called hping3. It's a very powerful network testing tool. I use -a to fake the identity of the source. I want to make the router believe the traffic comes from this particular IP address, which I got from the lower part, the very first example, right? Then this parameter is simply the destination machine, which is the left side of VLAN 88. Let me run it. See, in the lower right, you see the logs in real time. We have successfully simulated this alien connection. Then let's examine what's being logged. You can see it's with this description, alien block. The input interface is VLAN 66, output interface VLAN 88, makes sense. And then the source is the fake IP address which I used in the hping3 tool, and the destination is the VLAN 88 computer. It's a simple TCP connection. And then you see multiple logs simply because the hping3 tool tried multiple times. We are good from the backend syslog perspective. However, you may know for UniFi Network Controller, there's another place to see another type of so-called logs. See this button? Let me click on it. By the way, I filtered out this low severity logs just because I don't want to show you all the unnecessary logs, right? But you can see for this security related information, there's nothing captured in the logs on the UI. This is disappointing. Yes, something happened in the backend, but you won't realize it because there's nothing reflected from the UI. So this is for alien. Let me kill this tail command. Then let me show you another file in real time, tor block. Then in the left side, let me show you the IP set for tor. In the same way, let me pick the first random example IP address in the VLAN 66 command. Let me use hping3 again. In the same way, I fake this source IP address to this first one in the TOR list, and then the destination is the VLAN 88. Let me run it. In the exact same way, in the tail command output, you see the logs generated in real time. So we have seen the two IP reputation blockings work in action. Before moving to the deep dive, there are still two things I want to show you. First, the detection mode and its impact to the behavior, if any. Then the second thing is detection exclusions, how it's related to this IP reputation blocking. Okay, so first one, the detection mode. Notify means it's IDS, detection only. Notify and block means it's IPS, detection prevention, right? That's straightforward. However, when it comes to this IP reputation blocking, this setting becomes very confusing. Let me show you why. So now I have the notify setting, right? Because the two IP reputation blockings are inside the active detections. Of course, people will think this detection mode will apply to the IP reputation blocking as well, right? Which means it will not really block, it will simply notify. However, in the backend, in IP tables, let me show you the corresponding IP table chains. Then scroll to the beginning. You can see, for example, this alien log and drop chain. See the very last rule is drop. Even though on the network controller we say notify only, in reality the system will drop the packet. The same thing happened to TOR as well. This is a drop, right? What if I change the detection mode to notify and block? Then let me show the IP tables again. See, yes, there are changes in IP tables. For example, here you can see the IPS, log, and drop, right? And you can see a drop for regular IPS, which reflect the change we just made, notify and block, right? However, if you check the original alien and TOR, you can see nothing's changed. It is still drop, which means Ubiquiti has a very confusing web UI design. So for these two IP reputation related blocking, the UI give user the impression that they are part of the IDS IPS. However, this detection mode setting doesn't really apply to the IP reputation blocking. Then let's talk about this thing, detection exclusion. So let's see how or whether this exclusion will impact the IP reputation blocking. Click on create new. Let me specify a IP address. So in the lower part SSH session, let me run IP set. Get some example IP addresses from the alien list first. Let me use the very first one as an example. Add changes. Then let me add another one. This time, let me use the TOR list. Still use the very first one as an example. Add new. Okay, two IP addresses are added to the detection exclusions. Apply changes. Then let's see what happened in the IP tables. What's the effect of these exclusions? Let me show the IP tables again. Look into this alien log and drop chain. See the very first two rule. If the source IP address match a whitelist, it will return, which means it will allow it. It will not drop it. Then the second line, if the destination IP address is in a slightly different IP set, it will allow it. And then for TOR, log, and drop, you see similar situation. It's just this time we have another two IP sets with slightly different names, right? In total, we are talking about 4 whitelist IP sets. So let's see how these two IP addresses we added from the UI, how they are implemented in these 4 IP sets. Let me show the first IP set. Interestingly, it contains both IP address. Do you still remember how we ended up with these two IP addresses? The first one, I picked the random example from alien list. The second one, I picked it from the TOR list. But in the backend, both are added to the alien related source list. So let me continue checking this time for alien whitelist, but for destination, the exact same situation, two IP addresses, right? Now you can safely guess for TOR, we have the exact same values for both source and destination. Let's validate. Yeah, for source, the same two IP address. For destination, the same. So which means Ubiquiti's solution or implementation for the exclusion list is not very elegant. On the UI, you input whatever IP addresses, but the system doesn't correlate your IP address to the alien list and TOR list. Instead, the system will blindly add whatever IP addresses you input to the 4 whitelist IP set. So the end result is correct. Whatever IP address you input in the exclusion list, it will appear in the whitelist for both alien and the TOR, right? It will have the job done. What I'm saying is, from backend perspective, the implementation doesn't look good. Then go back to the UI design. If it was me who designed the UI, I would separate the two IP reputation blocking out of this active detection. I will have a separate IP reputation blocking section and move the detection exclusions into that new section, so that from the UI perspective, it's very clear the detection exclusions are specifically about the IP reputation blocking. Then you won't have the detection mode confusion. That's another benefit. So I hope Ubiquiti can make the change in future releases. Okay, enough about the UI design. Let's move to the very last section of this video. Let's deep dive to understand how the Syslog routing works when it comes to IP reputation blocking. Do you still remember where we found the logs for IP reputation blocking? It's under this folder, right? So it's a subfolder named as ulog in log folder. You may wonder what's ulog at all, right? Let me search ps to see whether any running processes with ulog in the names. See, there's one process. It's called ulogd and it's running in daemon mode. This is a crucial process in the whole routing of Syslog for IP reputation blocking in UniFi gateway. As shown in the diagram, the ulogd is a producer. It will produce the information which in the end will be represented as logs. If I run ulogd show its help, you can see it's version 2 and it's a free software. Here I'm showing you a web page from netfilter. You may know IP tables is from netfilter as well. So here you see the ulogd2 information. If I show the IP tables one more time, you can see for alien log and drop and TOR log and drop, for the NF log, they all specify a thing called NF log prefix, which is a string, and NF log group. And for both of them, the group number is 3. Later you will see the 3 plays an important role in the whole routing of Syslog. Now let me show you the configuration for ulogd, which reveals a lot of interesting information about the whole Syslog routing. Go to etc vi the ulogd.config file. We will discuss the details in my next video about Syslog. Here we only talk about the part which is related to IP reputation blocking. See this plugin? It's about NF log. So by using this plugin, the ulogd is connected with the NF log target in IP tables. Whatever NF log is going to log, the data will flow to ulogd. Then see this stack. For ulogd, stack means it defines the data processing pipeline. This particular stack is related to this video for IP reputation blocking. For all the sections which are separated with comma, they are in the same pattern. Each of them has a colon in the middle. Then the part before the colon is just a name after the colon referring to one of the plugins. So you can see for this particular stack or pipeline, it will use this data and then at the end it will be generated as part of the Syslog. And Syslog here, in fact, is another plugin. So basically this stack defines the pipeline. The data will flow to Syslog in the end. Then if we continue looking, you can find these two sections. Okay, for IP reputation block, it will use group 3. Remember when we check IP tables, we also see this group 3 thing, right? And then for the IP reputation block Syslog, it defines facility and the value is local file. As I noted in the diagram, a facility is a classification tag that indicates the source or type of the log, and then local file is a custom value So basically it's just used to classify the type of the log, and you will see this one later will be used to filter out which log is related to IP reputation blocking. So this is the related part in the ulogd, and it is in the producer side. So once the data is produced, it will flow to the consumer. There are multiple possible implementations regarding Syslog in Linux. The one Ubiquiti chooses in its UniFi gateway is Syslog NG. Syslog NG is a consumer in the whole data flow or routing of the Syslog. Then let me show you the process about Syslog. There is one. It is Syslog NG. In etc folder, let me cd to Syslog NG. Then you can see there's another subfolder called configuration.d. And there are a lot of files in this folder. They are all very interesting, but in this video, let's focus on this particular one, IP reputation log configuration. It is used to filter the related log and to decide how to output them. Let me vi this file. You can see here it defines two destinations. These two files are exactly what we saw previously in this video. This explains where they come from. And then see here, this filter, it will only deal with the logs which have the facility local file. Remember earlier when we checked the ulogd configuration, it specifies for IP reputation logging, it will use facility local file, right? And then see here, it will identify which log is about alien, which log is about TOR, just by checking the string to see whether it has this particular string or this particular string. If you remember, these two are exactly what we saw in the IP tables for the NF log target. And then here it's just to execute it. It specifies all the filters to accomplish the final output of the log information in one of the two files. Now we can understand how the IP reputation blocking information is generated from the NF log in IP tables and then output to the producer, which is ulogd, and the ulogd will use this particular plugin and specifying a special facility to output the respective log information to Syslog NG. And then Syslog NG will, based on this configuration, to decide how, where to log. Okay, I hope it's clear. This ends the video. Thanks for watching.